So hello and welcome to our first Symphony podcast ever. I'm Lehel Papacek, and I will be the host for this first episode of this new format of learning that we are launching. So basically, this is a place where our engineering community comes together and gets the opportunity to hear the discussions on different tech topics. That's pretty new for us as a company. We are delighted to introduce for the fall join to this podcast one of the biggest names in the software engineering industry to help us answer some of the questions raised by our engineers in Symphony. So our guest tonight is Mark Richards, who is an experienced hands-on software architect with over 35 years of experience in the industry. He is involved in the architecture, design, and implementation of microservices architecture, service-oriented architectures, and distributed systems. Also, he is into a variety of other technologies too. Mark is the founder of developer-to-architect.com, a free website devoted to helping developers in the journey to becoming a software architect. And also he is an author of numerous technical books and videos, including the fundamentals of software architecture. So that was a lot, wasn't it? So hey, Mark, how are you? How are you tonight?
Hi, great. And thank you so much for inviting me and having me on this podcast. So thank you.
Great, nice to have you here. So yeah, as I said, we in a couple of weeks before this podcast, we collected a lot of questions actually from our colleagues across Symphony hubs all around Europe. So I think the agenda would be to basically get through them as much as we can. Probably discuss, in a bit more detail. So some of them, and just generally have a nice discussion regarding all these tech-related questions.
Mm-hmm.
So I think like one of the opener question would be, as you're being a software architect, maybe regarding the position itself. So it would be, what's the best way for a solution architect to demonstrate their vision, keeping in mind that it should both work for management and development folks? So is it a proof of concept? Is it some kind of documentation? So what's your take on that topic?
Yeah, this is actually one of those really hard pieces of architecture. And I appreciate the question because it is difficult. And not only from just demonstrating and explaining our vision as an architect, but also documenting it. One of the things we don't have in our industry as architects, or actually even as developers, but we'll just say as architects, is a common standard around the world for diagramming and conveying what we'd really like to do. Building architects have this, and if a blueprint is created in Singapore, an architect in Canada can see it just fine and understand it. We don't have that, which makes it a little more difficult. There are some standards that are emerging, such as the open group. Archimate is one such standard, but a lot of architects, including myself, don't adopt those. And so we still have this problem. But it's interesting. I really liked the part of the question that you just read in terms of development, management. I'll even throw in operations. There's a lot of different kinds of stakeholders who want to see different perspectives of our architecture that relate to their agenda. And this makes it equally as challenging. What I usually do when I try to demonstrate a vision for an architecture, if I come up with kind of a solution or an idea, this is what I'd like. I usually start out with an architecture presentation. And it's quite interesting. I never used to do these until I started using ATAM. And this goes back many years ago. ATAM is Architecture Trade-off Analysis Method. One of the first things in ATAM is to create an architecture presentation. And I thought about this and I thought, why don't we do that? A lot of architects do, but a lot don't. And it really is an effective way of focusing on describing the architecture in various levels to different stakeholders. And so in these kind of, if I'm going to present my vision, I usually do a brief recap, for example, of the business problem or the issues to tie it back to the architecture. Too many times, and I think this is an important part of conveying our vision, because too many times it's like, so this is what we're doing, and look, we're having all these services and they're going to communicate this way. And it's like, but I don't see how that's going to solve some of our problems here. And so by describing my architecture and vision, I like to actually recap those issues, the business need or business problems, give an overview, kind of a very contextual view of the architecture, and really start tying it back to how it solves some of the problems. And this is usually an effective way, both with management who needs validation that I'm addressing the problems, but equally as important with developers, because the development team also needs to understand the why piece and really understand the context. And then I usually move into things like user journeys, sequence diagrams, to really show how certain workflows work within the architecture. This is a hard piece, but that's usually my technique that I use for kind of demonstrating that overall vision. At least initially.
And also, so as you mentioned, some of the new tools may be emerging to fulfill these needs. So do you think that we could actually in the future have a tool, let's say like an industry standard tool for documenting architecture and things like that, or you think that maybe the ways how architects work is way too saturated to do that?
This is tough, because unfortunately, like every answer, it comes down to it depends. I do use tools, but generally my preference in diagramming and explaining architecture are free-form tools. Things like Draw.io, Visio, Omnigraphal. I'm a Mac user, so I use Omnigraphal. A whiteboard even. These are, for me, very effective ways to convey that architecture. A diagram is really trying to convey a shared understanding of the architecture. And if the tools start getting in my way of trying to convey what I want to show you, that's the time I usually abandon those tools and move to other sort of drawing mechanisms. The tools have a lot of value though, because unfortunately, with a lot of free-form diagrams, when I make a change to the architecture, I have to make sure every one of those diagrams and views are also correspondingly changed. And that's the drawback. The tools, especially with Archimate standard tools, which I think there's more than 35 of them now, these are really effective. If I break apart a component, I do that in the component portion of the diagramming tool, and all the other views are then just regenerated. And so it really adds to that agility of changing the architecture and not having to worry about all the different views and changing them. I have to regenerate them, but at least some tools, not even that. But there's the trade-off, really. And it also depends on what I'm trying to convey. That's why I really do make good use. I don't use UML often as an architect, but one of the aspects I do use are sequence diagrams. There's a wonderful way of showing the flows between components, especially really complex workflows.
Mm-hmm. Yeah, that makes sense. And also, as you mentioned, trade-off. So generally, when making new architectures and generally new solutions, so do you have a way to maybe categorize the trade-off? So what trade-off is worse than the other one, and things like that? So do you have maybe a framework on your own that you can use for that, or what's like the best way to tackle that problem?
Yeah, so when Neil and I finished our book, Fundamentals of Software Architecture, was published, in February of last year. Prior to that, we had already started work about 6 months prior to that on our follow-on book, which we just finished the draft, which is Software Architecture, the Hard Parts. And so that's been almost 2 years in the making. The reason I bring this up, Lehel, is that one of the things Neil Ford and I tried to do was to see, is there a framework that we can develop for analyzing trade-offs? And, some frameworks or processes, I'll call them frameworks, do already exist, ATAM and CBAM. ATAM being architecture trade-off analysis method, and CBAM being cost benefit analysis method. Of late, these two have pretty much been combined. They used to be two separate ways of analyzing trade-offs, one based on cost, one based on business needs. However, of late, they've kind of been combined. My strong feeling, loosely held, is that these type of frameworks are too prescriptive and don't really take a lot of the scenarios and agility into account. But we worked really hard to try to see, since the subtitle of our book is Modern Trade-off Analyses for Distributed Architectures. And unfortunately, that silver bullet, at least we could not find. There's too many different contextual aspects with regards to trade-offs. And of course, it all has to be based on not either, but business drivers which translate to those architecture characteristics. And while we couldn't find a framework, what we did identify in the book, dozens and dozens of categories of techniques and tips for kind of how to do trade-off analysis. But yeah, we tried to look for that. We tried to develop that, Lehel, and unfortunately, it's too broad, too dynamic, and not deterministic enough, unfortunately, to have a good framework for trade-off analysis.
Yeah, but definitely looking forward to the new book.
Yeah.
Okay, and also while we are at trade-offs and generally in this topic, regarding architecture health, so is there something that that we can use for measuring the healthiness of the architecture itself? So for code quality, we have static code analysis, we have complexity analysis and things like that. But for traits like fault tolerance, scalability, and the other ilities, right? So how we can measure that, right?
Yeah. So this is something of I love this kind of question, because it really is. I get on a couple of soapboxes about it. Really, one of the most effective ways I found of actually measuring a project's health is through what are called fitness functions. And these are particular functions that we write, or we can leverage tools to do. As a matter of fact, the whole Netflix Simian Army is a fitness function. All of the various latency monkey, security monkey, identity monkey, all those are in fact fitness functions, because what these do, there's many categories of them, but basically they run in the background, analyzing particular architectural characteristics to measure either structural decay or the overall health of our application. And they do so through either trend analysis, which are most of the ones I write, or threshold analysis. In other words, maybe reaching a maximum response time of, let's say, 2.5 seconds. Notify me if that happens. I don't care for threshold ones much, because there's too many false positives. We knock out a server, the database goes down, and these trigger, unfortunately, a lot of fitness functions. Trend-based, in my opinion, is much more valuable, varying, of course, the time period in which we are analyzing that trend. But here's the value of these, and I want to talk about how to create these. The value of them is not only to demonstrate, are we reaching our performance or security or fault tolerance or even agility goals? That's one purpose. of measuring a project's health. We just implemented a lot of pretty major features in our application release, and we just deployed to production. Did we impact fault tolerance, security, performance, any of these? And these fitness functions allow us to know, let's say that our scalability was great, and all of a sudden we did a deployment and the curve starts trending this way. We notice that inflection point, we can track it to a particular deployment and be able to say, based on those new features, we just impacted a major characteristic that was needed by the architecture. And so they really do solve both of these problems. They not only inform us or not only demonstrate that we're doing something right, or maybe not, but also as we're applying changes to our system, are we impacting these? However, one of the tricks is understanding what to measure. And this is where I might get on a little soapbox. I'll try not to. I see too many teams trying to do premature optimization of performance, for example, or starting to measure responsiveness and performance and say, well, look, it's getting worse. But we don't care about performance. And so the bottom line is knowing what to measure is just as important as actually measuring it. And this ties back to the prior question that you asked about the trade-offs. In order to analyze a trade-off, A or B, we have to know which is more important, responsiveness or extensibility. Which one do you want? And again, it ties back to those core business needs, business drivers, which then translate to the characteristics. And so again, this is a starting point, understanding what ilities, what I call them architecture characteristics, but a lot of people call them ilities or quality attributes or non-functional requirements. These are all the names for these things. Which ones are important to us? And as a matter of fact, if you go to, and let me see where these are here. I'm just going over here to resources. Let me just see where these are. So in my website, developer2architect.com, and it's all one word, in the About Me section, which is the last link, if you scroll down to the very bottom, you'll see other resources. And those are some architecture worksheets that you can actually use. These are actually ones I use at work. That help you identify these kind of architecture characteristics. But it is, in my humble opinion, a necessary exercise in order to do trade-offs and in order to measure a health of an application. So
I think that's a great tip for our engineers and architects in general, because you just need some format to evaluate your ideas. So that's great. Thanks for the tip.
Yeah.
And yeah, regarding the practices and the things that you've seen on projects in general, do you have maybe an example of a thing that sounded really good in theory, but then turned out as hell when implemented and used in practice? Maybe also regarding fixing something in the production, but then also degrading some other characteristics of the architecture.
Mm-hmm. Oh yeah, microservices.
I kind of
next question. I couldn't help myself. Something that you described turns out really messy when you try to implement it, but sounds really good from the start. That was the very first thing that came to my mind. I had to say that. but no, there are quite a few things that do come to mind. Really, things that sound good in theory. There's so many. Wow, I wish we had all day for this. But really, breaking apart data is the first thing that comes to mind. In theory, we see all these patterns and refactorings and practices for breaking apart monolithic data in a distributed architecture. And in theory, it all really looks good until we actually try to do it. And that's the first thing that comes to my mind is really the difficulties in really breaking apart data, especially relational data. In theory, with especially microservices, we try to do this database per service pattern, forming tight bounded contexts. Basically, I just described microservices, single purpose functions deployed as separate units within tightly formed bounded contexts where each service owns its own data. Man, that's awesome. That's great. It solves a lot of problems, introduces a lot, but it solves a lot of problems. And it looks really great in theory until you take a standard relational database and you see foreign keys everywhere between the tables, dependencies like views or triggers, maybe even some stored procedures still in there. And now what we start to break apart that data, it's just really, really messy to try to implement. As a matter of fact, the other thing that immediately comes to mind is the whole notion of a bounded context. I love this concept by Eric Evans, and it's how microservices works. Microservices would not exist without a bounded context. Love the concept. It's really awesome in theory until we actually try to form tightly formed bounded contexts. And in most business applications, based on the relationships between functionality, workflows, and data, it's not as easy as it sounds. I think, last one that really comes to mind that sounds good in theory are really the ideas and notions and books that we read about breaking apart the monolith. We talk about monolithic applications and migrating them to microservices or service-based or some sort of event-driven maybe. This is what I've been doing for 6 years, helping companies move to microservices. And, with all the patterns and everything in place, great in theory, but it really is super difficult to implement some of these things. Theoretically, you take two components and you split them apart. But what if those components have shared code between them? Or what if they need to talk to one another for functionality? There's all these really hard things that come about. And so, there's a lot of things that sound great in theory, but event-driven architecture comes to mind right away. In theory, you just fire off events and you respond. You trigger events and respond to events. I mean, what could be so hard? Except when we have 3 events that all need to be processed at the same time. How do we control the timing of those? How do we aggregate events when in fact we got to wait for it because it's all asynchronous? How long do I wait? I've received 2 events. I should be receiving the 3rd one right away and it's never showing up. And it's like, well, I need the 3 of these events. Well, the 3 of these events in order to continue processing. Now, what do I do? These things are really, really, really hard. But in theory, it sounds great. Those are some of the immediate ones that really come to mind.
Yeah, and I think we pretty much touched on several other questions here too. But the topic is really, really interesting because I think a lot of engineers are struggling with the very same problem. So I also think about like distributed transactions, which is one of the hardest things also to achieve, for example, in microservices architecture. Mm-hmm. And also I wanted to ask you regarding these maybe periodical hype trains when a new technology comes out and everybody is so excited about it, but it sounds good on paper, but when you try actually and see the caveats of the solution, then you are in a problem. So,
oh yes, and as a matter of fact, Lehel, this is why architects are generally always in a bad mood. They're never excited. They're always walking around with scowls and frowns and stuff, because most effective architects understand that everything has a trade-off. And when somebody comes up to you and gets all excited about a particular technology or framework, and really starts just like, isn't this great? Isn't this exciting? An effective architect will say, yeah. It's like, why aren't you excited? It's like, I'm waiting for the other shoe to drop. What's the trade-off? Because there is one. If I'm getting 10 times performance increase, what am I losing here? What's my price I'm paying? And architects absolutely understand that need to analyze those trade-offs. This is a cautionary tale, and by the way, Lehel, that both Neil Ford and I evangelize in both of our books, not only the fundamentals, but our upcoming one on the hard parts, is cautioning architects to not over-evangelize a particular technology or framework or practice, because there are trade-offs associated with it. And by evangelizing it, what we're unfortunately doing is accentuating some of the trade-offs over here, but not really talking about the trade-offs here. And so this is one of those things that's really a cautionary tale. Now it's really hard because I tend to evangelize quite a few things, but I'm always careful to not over evangelize, but also indicate what the trade-offs are, the pros and the cons associated with any solution.
Yeah, that makes sense. And also regarding the maybe so the transitions from one architecture style to another, when we actually figure out that maybe a high train didn't work. So is it something that you have seen? So maybe like a backward transition, because we always talk about, monolithic to microservices and things like that. But what happens with projects that started as microservices for whatever reason, and then it's figured out that there are problems that cannot be easily solved? So what's your take on that? How we should approach that problem? So should we try to go backwards in a way, or how to tackle that problem?
Sure. Yeah. And as a matter of fact, I do see this quite often, as a matter of fact. So there's kind of two parts here I see. There's a going backwards, but also maybe sideways and choosing a different kind of architecture style. But yes, I see this quite frequently, as a matter of fact, in my travels, where companies will embrace a microservices architecture and really take the word micro to heart, and unfortunately create services that are in fact too fine-grained. And now those services are all communicating with one another. They're all dependent on one another. They all need each other's data. And unfortunately, what results is, quite frankly, a big ball of distributed mud. In those cases, a lot of companies I've been involved with, and a lot of projects, were actually to move from microservices to service-based, which is more coarse-grained services. I have frequently seen this bouncing, more so in the first 4 years of kind of doing microservices than now. I still see it, but I saw it quite frequently back about 2 to 3 years ago. Companies going to microservices and even implementing maybe all the way to kind of serverless deployments, and realizing we can't even manage anything. We can't change a service without redeploying the entire ecosystem, and then rubber banding back to more coarse-grained domain-based services where we're sharing more data, sharing more functionality. And that is more common than you think. Based on some of that experience of this rubber banding, I do have advice that I usually give most companies, whether it be migration or greenfield. And that is, from any sort of monolith, whether it be a modular monolith, layered, unstructured ball of mud, first move to a service-based architecture where we have coarse-grained, separately deployed services, but these are domain services, all sharing data. At that point, we can identify discrete domains, which we can then start breaking up our user interface to match those. And then, where necessary, start breaking up a domain service further into microservices. You see, one of the anti-patterns that I've found is teams assuming that everything in the application has to be microservices. And at least in my experience, most cases, that's not always true. Your admin functionality does not have to be microservices. Your backend reconciliation process does not need to be microservices. You're getting no benefits, but all the negatives associated with microservices. So yes, I do see that backwards thing happening quite a bit. By evangelizing this forward movement of iteration to microservices, I'm seeing much less of that now. But moving sideways, let's say we're going for a microservices ecosystem, or architecture, but we realize, yeah, but you know what? We've got all these services, we're doing this, but we realized we're really firing and responding to events. We need to really move to an event-driven architecture, or space-based for elasticity, or all these other kinds of architecture styles and hybrids. And really, here's the advice there. Is the more modular your architecture, the easier it is to transition to the different styles. And when I'm talking about that modularity, it's not always just saying, oh, so you mean have lots and lots of services? Well, architectural modularity is structural, which means, yes, we may have modularity within multiple services, but also within a service. If we can kind of focus on components and domain-based components rather than these layers that we continually do, that also helps in kind of pulling pieces off, extracting them, and putting them in different services. So yeah, it is a lot about modularity.
Yeah, and also, is there a moment in a life cycle of an architecture, basically, when it's too late? Maybe when probably there are several factors there to be considered, but when it's maybe just too expensive to move sideways, when the solution still works, maybe it's not the best fit for the problem. So there's the trade-offs. So where we should move, right?
Yeah, I don't know if I've ever been in a situation where we say, nope, it's too late, we got to stick with this. Architecture, at least in my opinion, strongly held, is an iterative exercise. Architecture evolves. In today's world, it doesn't really work to basically create a grand plan for 4 months and then have development teams go and implement it. That model, which may have worked 20 years ago, and I still doubt whether it actually did, but that was what we tried to do or did. Really, in today's world, change is too rapid. And so small iterations to refactoring an architecture, and what I mean by refactoring an architecture is changing the structure, breaking apart services, putting services back together, communicating with services we didn't before, new interfaces, maybe it's breaking apart data. These are structural changes to our application. And for those, I like small iterations to reduce the risk, but I also leverage what are called architecture stories within an agile any sort of agile environment. Changing an architecture and starting to either go backwards or sideways or starting to evolve to another one. I've not had any roadblocks of saying, well, it's too late, you can't. But small changes and iterations through architecture stories usually facilitate that movement. This is not technical debt. This is why I don't create those as technical stories or technical debt stories. What's driving usually that architectural change is a business need. We have to scale better. Our customers aren't satisfied. We have to give them faster response time and more reliable systems. Our data is inaccurate. These are business needs. It's not technical debt. And that's why I like to create separate stories for these so that I, as an architect, can negotiate with the product owner and say, in this iteration, I'd really like to do a 2-point story to break apart this particular service because it's not scaling. And so that's really how I try. So almost every iteration, we've got usually, well, not every iteration, but a lot of iterations. We do two in microservices, two very common refactoring patterns: service split and service consolidation. Services breaking apart, putting them back together as we learn more about the system, about its usage, about fitness functions that we run in the background, etc. You know, it really is an evolutionary process.
Yeah, it is. It is really. And breaking apart services. Have you ever seen a system with like well-designed boundary context? That kind of reverts back to a topic of microservices and everything.
Yeah.
So, have you seen that like in the wilderness?
Over the course of the past 6 years, I've been at dozens and dozens of companies and teams. Yes, actually, I have seen really well-formed bounded contexts. However, probably the majority I've seen struggles with. It really comes down to mostly the challenges I see in poorly formed bounded contexts is about the data. But let me qualify what I mean by a poor or a well-designed bounded context. Let's say that we've got 3 different shipping services. So we're shipping through DHL, FedEx, and UPS. And I've got those as 3 separate services rather than one. Let's say I have reasons for doing that. Maybe it's code volatility, maybe it's scalability, throughput. Let's say I've got reasons for keeping those 3, but they all need the same data. And so I might create a data domain so that the single data schema is shared now by 3 different services. Where I draw my bounded context is around those 3 services and the shared data. I would consider that a well-designed bounded context. Because I've got services. Now, what we try to do, of course, is each service needs to own its own data. Well, that's all well and good until we get into multiple ownership issues, data access issues and stuff. And so if those 3 shipping services need all access to the same kind of shipping data, that's a well-formed bounded context. It's okay to share data in microservices. It really is. And the use cases for that are all those artifacts I talked about before. Foreign keys, maybe there's some views or procedures, triggers, stuff that we can't break apart. They have to stay together. Multiple services that write to a table. Sometimes we could do table split, but one of the most effective ways is to say, well, then let's share the data together. And so that I would consider well formed. So I would say about half of all of the applications I've seen or worked on or analyzed or assessed really do have really well-formed bounded contexts. The ones that don't are the ones that cross over lines for data and start accessing different databases, and that's not a bounded context.
Yeah. And I think, I mean, you touched a really good point here regarding data separation and multiple services writing maybe to the same table, because there are opinions where people are saying that basically every microservice should have its own database. So it kind of brings us back to like maybe some hybrid architectures where we have part of it could be microservices with separate databases. On the other side, we can have a service-based architecture, right, where services are sharing the database, and it's really nice to hear that it's fine.
Yeah, exactly. And those hybrids are actually what a majority, I won't say all, but a majority of the business applications I have worked on in the past 6 years in microservices were really those hybrids that you just described. Yeah, and it's extremely common. And I rather like it, as a matter of fact, because it's very pragmatic and we're using the right tool, i.e. the right architecture style, for the right problem. Administrative functions of maintaining users and reference data, name value pairs in the websites, those don't need to be individual services. There's no reason, there's no justification for it. So yeah, those hybrids are very, very, very common. Yeah.
Yeah. And regarding the hybrid architectures, are there any caveats or maybe common pitfalls that you can share? So we know when we see one.
Oh man, there are so many pitfalls and anti-patterns that exist. Yes, there are pitfalls. One of the main pitfalls is using too many architecture styles. In other words, well, we've got a space-based microservice, event-driven SOA, serverless architecture. And it's like, what? Mixing too many, suddenly you can't even identify what the architecture style you're actually using. 2 to 3 is good. Any more than 3, and we start to question maybe these should be in different systems as opposed to a single application context. But here's the other pitfall that I see happen a lot. Neil Ford and I, in our book, The Fundamentals of Software Architecture, did star ratings for each of these kind of things. As a matter of fact, those workbooks I mentioned, one of the workbooks in my website is, in fact, those star ratings, that consolidated star rating chart. So we rated from 1 to 5 stars all the various architecture styles in terms of various characteristics. One of the pitfalls that I see is teams going, oh, well, look, Mark and Neil rated event-driven architecture as 5 stars for performance, yet we're doing microservices, which is 2 stars. Well, let's do an event-driven microservices architecture, because now we'll take those 2 stars and we'll move the 5 stars from event-driven, and that satisfies all of our performance requirements. Until you realize microservices has 5 stars for testability. Event-driven architecture has 2. So the bottom line is, the pitfall I see is getting excited about moving the 5 stars over, but forgetting when you form a hybrid, you're bringing over the good stuff, but you're also bringing over the bad stuff. And whereas we had beautiful testability in microservices, now goes down to maybe 3 stars, and it becomes hard. And so when forming hybrids, again, it's analyzing the trade-offs of what we're getting with that hybrid, but also what the bad things are.
Yeah. Yep. True that.
Yeah.
So let's talk about serverless, because you also mentioned it, and we are also there are discussions popping up regarding serverless in the company from time to time. So I saw in one of your lessons that you and Neil Ford are considering serverless as a deployment strategy more than an architecture style. So so in your opinion, like, what's the current state of microservice of serverless, when to use it, when not to use it, basically where we are headed with serverless?
Yeah, and I do maintain that opinion, and it is an opinion of mine, that serverless is not an architecture style, but you are right. It is, in my opinion, a deployment strategy. When we think of serverless, and if you were to describe it, how would you describe it? It's like, well, I've got small single-purpose functions. They're all separately deployed. I don't require containerization, and they're triggered. Well, what I've just described, quite frankly, is microservices, single purpose functions deployed as separate units of software. But the architecture style isn't saying how they need to be deployed. And that's the rationale for really saying serverless is really microservices, but in a different kind of deployment model, where functions are triggered, start up, perform their function, and end. So that in an idle state, I am not spending a single penny. That's the promise. In my opinion, and this again, a strong opinion loosely held, I believe serverless is an overhyped deployment model. I have seen too many teams that embrace it because it's a cool thing to do. Teams tend to do RDD, which is called resume-driven development, meaning let me do these things in serverless because I want serverless on my resume. I think it's really cool. I want to be known as I write lambdas, I write Google Cloud functions, and the problem is, again, it's that jumping on the bandwagon piece that I see. The same thing with microservices, the same thing I see with serverless. I actually have been reading a lot of articles and just different commentary about serverless not meeting its promise. I do concur and agree with a lot of that analysis. I think there are certain features and functions of an application that are really well suited for serverless. Those functions that, for example, we don't invoke a lot. We don't need 5 instances of a rate calculator or a discount calculator open. When we invoke it, spin it up, the thing we forget about it are all the cold start aspects of serverless functions. And while Microsoft or Azure are kind of addressing some of that issue with their frameworks, nevertheless, it is a drawback of serverless. And so there are trade-offs with using containerized functions, whether on-prem or cloud, and the same thing with serverless functions. And so my opinion is kind of when to use them, when not to use them. A lot of the promise of serverless is really, well, it's ease. There's a couple of promises. What most of the articles I've read really point to the cost benefits associated with serverless. We're not realizing those because, unfortunately, we're continually triggering serverless functions. And so they're always operational. And so we're rarely in an idle state, except for maybe in the middle of the night, depending on the type of system we have. But we could do that same thing with containerized functions. We could scale it down to 1 instance when we're low, and then when load peaks, scale it back up to 5 in the middle of the day. We could do the same thing there. However, the place I don't see a lot of benefits from a cost perspective are functions that are continuously triggered. I don't see much benefit, quite frankly, in my opinion, for serverless. However, one of the things that we tend to forget about is there's another benefit with serverless, and that's the ease of deployment infrastructure. It releases me as a developer to be able just to push code up and not have to worry about anything. And so that agility is actually quite attractive. So it really is balancing, again, those trade-offs. Watching out for that cost promise, because that's where most companies say, gee, we're not saving any money, are we? No, not really.
So serverless were a new technology at one point. So so when a new technology comes out, basically how you evaluate it? So do you have maybe a pet project to try it on, or maybe some kind of framework to do a deeper assessment of a new technology? So what would be the best way to actually figure out is it something good for us or not?
Yeah, so there's a couple of things I do on any kind of new technology to evaluate or maybe recommend. I usually first try to look at the ThoughtWorks technology radar. It's free. It comes out twice a year. And ThoughtWorks has done a lot of the work for us to say, really, at least in their customers, in their context, with a lot of the luminaries and sages in our industry, to say, what things as a technology community should we be putting on hold, bracing, adapting, maybe going on trial? That's one of the first things. I like their commentary, and I look usually there first. However, I love to go to places like Stack Overflow. I post questions to user communities, my colleagues. What I want to find out when I'm evaluating a new technology is, what problems are people having with it? I love looking at the problem piece first. It really gives me insight into guessing or predicting the kind of problems and issues we might have. So again, like the radar, I try to leverage the technology community through some of these things. Like I'm using Stack Overflow as an example because that's every developer's favorite tool in the world. I don't know how we would actually develop software without Stack Overflow. I really don't. But then understanding those issues, I can better weigh the benefits of a new technology. But as far as pet projects, I am a fan, by the way, of trying new technologies, new practices, new techniques, providing that we try them out on non-mission critical parts of our system. So when you say pet project, I might take something that's non-critical, doesn't change often, it's not overly important, and try that technology on those kind of projects, and find out, well, here's the promise of this technology. But the thing that's not in all the brochureware and the documentation is actually how it works in our environment. Sometimes, if it's an isolated kind of technology, I will do a proof of concept. And I will put together test clients. I'll put together a mock replica of a particular group of services, and I'll try it out. And I'll write fitness functions for them, and I'll see the comparisons. Those are some of the ways I kind of evaluate and kind of decide, should we really use new technology? Like I said, I'm a big fan of this because the only way we know that it's going to work is if we try it out in our specific environment with our specific use cases. And that you really can't find in the ThoughtWorks technology radar, documentation, maybe Stack Overflow, but that's the value in trying these things out. Yeah. Mm-hmm. Big fan of that.
I think that makes sense to not have an isolated pet project just on the local machine, but actually trying it out on a real environment, right, on a cloud or somewhere else. Yeah. So talking a bit more about the architecture itself. So I have pretty much two more questions. The one is regarding the layered architecture, which is one of the most common ones. So why is that? So why we still use like layered architecture as like the go-to solution for every problem that we have?
Yeah, I commonly call the layered architecture the de facto standard architecture. I like to say, and it always happens, if you walked up to a development team and you said, hey, what architecture are you using? What architecture style? And the development team looks up at you and says, what do you mean? It's layered. But primarily, this is the way we've been developing software for almost 5 decades. That's going on 50 years. But Conway's Law is really the reason why it's still the most common architecture style. Melvin Conway was right, matter of fact, and I believe it was 1968. It was that early, which he recognized that teams or organizations will develop software that matches their company's communication and organizational structure. And he's right. We have UI developers, all in the team upstairs on the 4th floor. And we've got our back-end developers who are on the 2nd floor, our rules developers who are in another building. We've got our DBAs and database folks who really understand and can tune databases. Some projects I've been on, we actually have folks that write the SQL because they're that good at it and it's that complex. But do you see when I'm describing this? As a matter of fact, we have testers that test all our stuff. We have release engineers that release it into production, black box. What I've just described are all the layers of a layered architecture. And that really is the reason why it is the most common go-to. We tend to knock the layered architecture, and I'm really glad for this question because we tend to think, well, that's an old architecture style. Why would anybody ever go there to that? It's still a viable architecture style. If we have a structure like I just described in our organization, it works pretty well. We've got teams that develop the user interface, teams that develop the back end, database people. Good luck trying to communicate them with them all. But it is a still valid architecture style if most of our changes that we apply are at a technical level, because layered architecture is a technically partitioned architecture. In other words, we're delineating that application, usually through a namespace. Most websites are layered, really by the usage of it: presentation, business, shared services, persistence. And if most of our changes are isolated to the UI, this is a great architecture choice, folks, because if we chose a modular monolith, that's exactly a 90-degree parallel cross separation between our architecture and the ability to change it. And because I'm going to have to go to all these different parts of the architecture to continually change all the user interface piece, not just one layer. And so, yeah, it's kind of an interesting story. Most of us are haters now about the layered architecture, but it is a natural go-to that most people in IT have actually implemented and understand. Yeah.
And also on the other side of the spectrum, we have microservices. And it will be, I think, our final question because we pretty much run out of time.
Oh, wow. Yeah, you're right.
Yeah. So what's the next step for microservices, basically? So where we are going from here?
Yeah. I think the next step I would say with microservices, if I think about, maturity models, which I'm not crazy about, by the way, but if we kind of align with that kind of thing, what's the next? Is it growing up? When it becomes an adult, what's the next step for this? I think, in my opinion, it's for not to become a silver bullet go-to for solutions. In other words, there are 8 common architecture styles out there. As a matter of fact, there's 9 common ones. Microservices is one of those 9. And teams not using it as an automatic go-to, like what we used to do 40, 30, 20 years ago with the layered architecture. That, in my opinion, is the next maturity level of microservices. Understanding the capabilities of it and also understanding the complexities of microservices, which there's a lot of, and knowing whether your problem matches that architecture. I mean, we may have all the drivers of scalability, fault tolerance, extensibility, agility, maintainability, testability, deployability. I mean, these are all 5-star ratings, and this is the go-to for it. And we may have all of those needs. And we look down a little chart and say, well, this is a clear choice. Except when we go to implement it, we find that our problem domain, our application, isn't suited to small, fine-grained, separately deployed services. Our functionality and our data is all tightly coupled together in workflows. We need all that functionality for every request. And that's called domain to architecture isomorphism. Does the shape of our problem match the shape of the architecture? And so this is a cautionary tale about the maturity of not only this architecture style, but the use of microservices, that not all applications are suited for this kind of decomposition of our applications and data. Let's not forget the data. So I really think that's the next step. And I am really confident in my heart because I see this occurring now. More and more companies, more and more teams, I'm actually seeing, understanding the benefits and the drawbacks, and also this idea of our problem. Again, let's go back to the, we're not Netflix, that kind of phrase that we used to hear about 4 or 5 years ago. No, we're a business application. So that, in my opinion, is the next step for microservices.
That sounds promising. So I hope we will stick to that in the future. So I think this was a great discussion, and you shared many useful insights for our engineers around Symphony hubs. So I would like to thank you, Mark, for joining.
Sure.
And I do hope you had a great time here.
Yes. I always love questions. It's one of my weaknesses. And so anyways, thank you so much for having me on this podcast. And I hope everybody listening really kind of got a little bit out of it, learned something, and enjoyed it. So thank you so much, Lehel.
You're welcome. Great. So I think that would be all for the folks joined. So thank you for tuning into the first Symphony podcast, and we're looking forward to many more to come. So take care and bye-bye.